Today, we're going to talk about something I've promised for a little while and I haven't really covered it yet, Open HPC. So it's a great way if you are working as a basic system administrator and for some reason your environment has asked for research computing. This is a wonderful way to get started for free and it's really easy to do. So let's get right to it. So OpenHPC is kind of like a project slash repository of packages that are needed to deploy an HPC system, high performance computing. It can be, something as simple as one node or hundreds of nodes, thousands of nodes, multiple clusters. You can do lots of different things with the tools that come in OpenHPC, the repository, their project. Now, you don't need this repository to begin building an HPC environment. In fact, all of the packages that are in here are separate projects that you could pull in yourself if you wanted to build a custom version of these tools. The only reason this kind of exists is it's a great way to learn how all the pieces work together to do what you need to do to make a high performance computing cluster. So what is a high performance computing cluster? There are situations where people need to do a lot of large computations and they just don't have a big enough single server or single piece of computing equipment to do all of those computations at once. So they may need to run thousands of jobs and they'll want to they want all of those jobs to run consecutively if at all is possible. So maybe I've got a researcher that says, I need to run 100 jobs related to this equation, 100 jobs for this equation, another 100 jobs for this equation. And I need all of that output to come out at the same time so I can correlate the data in a reasonable amount of time. Because maybe those 100 jobs take a week to run, but they only have one computer and it can only run 100 jobs at a time. Well, they can rewrite using something called Slurm Scheduler, which is what we'll use. There are other options to tell 3 machines to run those 100 jobs at the same time, dump all of the outputs into their output folder, and then maybe run another job afterward to correlate the data and give them a full answer to their problem. So that's where OpenHPC comes in that lets you build that for them so that they don't need to manually manage all of this. And this also lets you build a larger clustered environment so that multiple researchers can use the same equipment at the same time in an effective way without waiting for each other or overcommitting resources so that other researchers can't do things, stuff like that. And that's all handled through these different pieces of software like Slurm or PBS or Condor. Those are schedulers. Then there's provisioning like Werewolf or XCAT, and there are others. And then you have things in here to help you manage stuff like InfiniBand networking if you need really low latency, specialty file system management if you need things like that. All sorts of different packages that you can tie into HPC, all available through this project so that you don't have to research and dig and find it all. So this is the main side to the project. Let me make myself go away here. OpenHPC side, it's a collaborative community effort initiated from a desire to aggregate a number of common ingredients required to deploy and manage high-performance computing Linux clusters. So there you go. There's information about them. I highly recommend you read this. If you do deploy, maybe consider being a member. Also participate if you want to work at the Git repo and help them maintain their versions and stuff. If you're comfortable as a developer, try to look into that kind of thing. The main part is down here in downloads. So the downloads are going to give you access to the repos to add. And it kind of explains sort of the baselines of what's supported, what distros they use, things like that. And then you can even go into install recipes. And this takes you to their GitHub page for, the different versions that they've got. They've got 1, 2, they even have 3, which looks like it supports EL9. That's awesome. So you can do Alma with Werewolf and OpenPBS, Alma with Werewolf and Slurm, Rocky with Werewolf and OpenPBS, Rocky with Werewolf and Slurm, and RHEL works too. They just plug those in there because that's just what a lot of people are using for free right now if they don't have a license for RHEL. And of course, you can also use OpenSUSE, OpenEuler. I've never heard of this. OpenEuler? Interesting. And that's for Arch 64. Here's x86 64. There used to be an ARM version of a lot of this, but it looks like maybe that's not available right now. But let's say we want to do x86 64 with Rocky, Linux, and Werewolf and Slurm. So Werewolf would be our provisioning system, and Slurm would be our scheduling service. So let's grab that. It's going to be a PDF file, and that's going to load for us. And then this is going to give us every step we need to follow on how to build our cluster, how to design our networking, laying out all the different pieces that you're going to need to learn how to use to build this cluster out for your users. So in this series, we're going to go through this document, kind of follow their commands and read tips and things like that. They're going to give you information about how this works. So you can see here, you've got your master. This is going to be your scheduling server and your deployment server, most likely. Then these are going to be your compute nodes. They're going to be physical. They can be virtual. They just need to be able to talk on the network to your file system, your head node, and your compute nodes. They need to be able to talk to each other too, because sometimes you can work parallel jobs, things that nodes can tie into together. And then these are all of the inputs and stuff, and we'll go over all of this in different sections as we get through the rest of the series. But the first part of this series is kind of how I build systems like this and what I use. So like I said, I use Werewolf. I don't remember if this version is going to be using Werewolf 3 or 4. I forget which version they're on now. So we're going to have to go through that. This is the new version. This is for 3, and I've only done 2x. So we'll have to see how that goes. But essentially, the way I like to build systems out like this is I like to start with an Excel file or some sort of spreadsheet type program to lay out what I'm going to build. So maybe I need one head node, one login node, and maybe I know I have 20 pieces of physical hardware. So those are 20 nodes that I have available. So then I lay out inventory information about those. If I'm going to lay out some virtual machines, then I lay out information about that, and I'll explain kind of how that goes. And then we'll build off of that. And then we kind of need to get a good idea of what kind of cluster we build based off of what the researcher's requirements are. So if they need really low latency networking, well, then I know I need to invest in InfiniBand, or it needs to all be virtual so that it doesn't actually have to use the network that much, as long as they're on the same nodes. Or maybe they need massive file systems and a lot of fancy bells and whistles that BGFS or Lustre can offer, or maybe NFS is enough. It just depends on what they need to get, how fast they need to get it, and really what you can offer. Because you can start with near nothing and go into quite a lot. And what's really kind of cool about this is it's built in such a way that you can easily upgrade, replace, implement, do downtime, do uptime with very little service interruption. Especially if your head node is virtual, obviously. If your head node is not virtual, you can run into some downtime situations, but we'll get into that in a different video. But the main point of this video is to get an introduction, look at what we're going to deal with here. So we need to get like a host name, SMS name, SMS IP. So all of this different networking needs to be kind of laid out beforehand. There's a lot of planning that goes on with HPC. And there's a lot of documentation that you should read in here before you just start copying and pasting commands. There's quite a lot of preparation. This isn't as simple as like Googling, how do I build a LAMP server using Rocky 9, and then getting a bunch of step-by-step instructions on how to install HTTPD, PHP, blah, 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 blah. It's not like that. There's a bit more that goes into this, and you'll need to kind of make some understood decisions about your environment in relation to these steps, so that when you're, installing OpenHPC Slurm server and copying the config file and you're setting seed groups and things like that, well, do I need seed groups? Is that important? Is this, like this? Install InfiniBand. I don't need that. I'm not going to do InfiniBand. This is going to be a full virtual cluster, so I don't have to worry about InfiniBand drivers and InfiniBand network support, things like that. So we can cut that out. OmniPath, cut that out. We can go through these steps, and that's what we'll do here in just a minute. Okay, so now that we've got our spreadsheet created, we've read through some of this, we understand how commands work and things like that, we're going to start grabbing information out of here that it's going to expect for us and setting it. So let's go ahead and take this little bit of info. Let's paste that in there. Let's see if it probably put it all in single lines. And for some reason in B. So yeah, there we go. So we need to make these kind of variables, basically. So what are we going to call it? We'll just call it Open HPC. And our IP address, that's going to be internal. So there's going to be two networks on the head node. One is a network that lets it get out to the internet and things like that. And one is going to be one that's pretty much just to manage your internal network. So let's do, I don't know, 10.0.0.1. And then what's that interface going to be called? Let's say it's probably going to be like ETH0, right? And then the provisioning interface, which this is going to be, okay, that's actually a little confusing, and I wish I didn't word it like that. So that's going to be IP address. This is going to be interface. This is going to be the provisioning interface. So that's going to be your second one. So ETH2 or ETH1, I guess. And then the internal net mask, we're just going to keep that simple. 255.255.255.0. NTP server, we're probably just going to use something regular like pool.ntp.centos.org, something like that, I believe is what they use. You can run your own NTP server if you have one available. I'm just putting stuff in here. So for BMC, this is remote management for IPMI, stuff like that. So maybe you want to set a single password for all your devices, and maybe you don't even want to do this. I don't recommend you skip this, but you know, you can just set something simple like admin, big one here, password, there we go, total safe. So here, how many compute nodes do we hope to have? For this small deployment that we're just going to show for this YouTube video, we're going to do 4. Obviously, you can do as many as you want to. Now, this is how you want your node addresses laid out. So let's see, compute nodes, we'll probably do something like, oh, I just realized this is confusing, and I apologize. This is actually the Ethernet device for the provisioning node. So this is our internal network. All of this is all internal. Keep it all the same. It's easier to lay out. So then since the head node is going to take 10.0.1.1, we really want to keep the numbering simple, but we don't have to keep it on the same subnet if we don't want to, but it is kind of easier. So we'll do 10.0.0.2 through 10.0.0.5 because that'll give us 4 nodes, 2, 3, 4, 5, yeah. And then what about the BMC network? This is where I like to do maybe another subnet. So we do something like 10.0.1.2 through 10.0.1.5. So that way it'll all match. This is where you get your MAC addresses for your compute nodes. So we'll have to fill that in later. I think that's enough for a MAC address. Maybe it's more than that. Is it 5, 6? I don't remember. But anyway, we'll fill that in. This is how you want to name your compute nodes. So a lot of people do like dash node 001 if they think they're going to go into the hundreds. 01 if they're going to stay in the tens. Maybe they want to do compute dash 01 dash 001 for compute section 1 node 1 in case you're going to have multi-sectioned high large clustering functionality. Like maybe there's a section of compute nodes that you want to be able to look at the name and know that those are only CPU nodes, or maybe only high RAM, or only GPU, things like that. Or, you know, there are other ways to tell those things. Some folks like to do it by the node names. This is kind of up to you as to how you want to delineate your compute nodes. For our stuff, we're just going to go real simple, node 0001, because we're just going through to 04. And technically, we should probably do 2 through 5 because the IP addresses are going to get confusing, but it's fine. And then if you want regex, since we know that the regex is going to be pretty simplistic, we're not changing a lot of things. It's literally going to be node 00, node 0 asterisk. So that way it'll grab all the nodes when we need to use commands to do things to all the nodes at the same time. Prefix, same thing here. We can just do -n, that'll grab it. Optional BGFS, we won't be doing that. Let's see what else is in here. Won't be doing that. Won't be doing that. Won't be doing any of this because we don't have InfiniBand and we're not making any crazy kernel changes. so we can delete that info. Where's the delete button? There we go. So now that we've got that laid out, that is our basics. So that we know we've got a head node that's going to be called Open HPC. We know that it's going to start with the IP address, internal IP address of 10.0.0.1. It could have a different external address based on what kind of network maybe you have in your environment. So maybe you have a VLAN that's dedicated just to HPC resources. The head node needs an IP address from that VLAN so we can go out and grab updates and people can connect to it, because they're not going to connect on this 10.0. That's a flat network that just exists for your cluster. So let's go back to our guide and see what we need to get next. So next we need to install the operating system. And as you can see, it's going to have you add the internal IP address and host name in your host file. So let's copy this command. This is going to help us kind of organize our thoughts. So we need to install base OS, Rocky 9. We'll go with Rocky 9 even though I've never done it. And then that's the first command we're going to run. It's going to explain why you should do that. And then it's going to say, hey, maybe you should turn off SE Linux because it can cause problems. Big shock and awe. I don't think I've read a single install document that says install with SE Linux. So if you've seen one, let me know. And then disable Firewall D temporarily. You are going to need Firewall D later, but for right now, they just kind of want you to turn it off. So we'll grab these two commands and plug those in. And then install the Open HPC components. So we'll grab all this. And there's the Rocky 9 EPL repos. You got to set those up and turn them on for access to certain packages we will need during the install. So we'll grab those commands and we will plug those in here. Now you might be wondering, why am I not just doing these commands right now? I'm building an install guide first that I can follow. And then what I like to do is once I've done a command, I will take and I will fill that in with green. I'll say that command finished successfully. If I run into a command, for instance, that doesn't run right, I'm going to mark it red. And then I'm going to insert a new row right. Well, not that way. I need to do above. Insert a row above. And then I'm going to say, okay, here was my error message. This is what happened when I ran the command. And then I'm going to find out what the proper command is that works for the environment. And I'm going to update it and mark that in green. And that's going to tell me that, okay, this previous command didn't work, but here's the command afterward that replaces it. And I'll even put a little note in here, fixes number 20, like fixes row 20 issue. That way I have full documentation on what I did during my install guide. So that when I go back later and go, why did that happen? I'll know. And then you build the provisioning system and install all the packages needed for Open HPC. So we'll grab these commands. You can grab those headers too if you want to make sure you're documenting exactly where you are in the steps. And then many server BIOS configurations have Pixie network booting configured as a primary option in the boot order by default. If your compute nodes have a different device as the first, the IPMI tool utility can be used to enable Pixie. So that's kind of a good little thing. All these nodes need to be able to Pixie boot so that they can pull an image off the head node. The head node is actually going to hold the images when we start configuring the Werewolf system. And Werewolf by default works as a stateless system. And that means that it doesn't actually install anything on a hard drive in the system. It just puts it in memory, basically. Everything's a temp disk, because there's a chance that your nodes may need to do multiple different operating systems based off of different jobs. Like maybe they need to run some stuff in Rocky, and maybe they need to run some stuff in OpenSUSE. Maybe they need to, for some reason, spin up Windows. I don't know why. I don't think there's a single reason I can think of that it would need that. So all those things kind of come into play here. And then we've got to make sure that time gets synchronized. So obviously we set up this service. We dump that in. And note that allow option, blah, 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 blah. Add resource management services. So, install Slurm, get Slurm prepped for configuration. This is all just to get Slurm started. So let's grab those. And we will probably stop there because we're getting a little long in the tooth. And this last command just kind of puts the Slurm, the name of your server in as the Slurm client host, so that they'll know in the future who they're supposed to be talking to get their scheduling from. We're not doing InfiniBand, so we'll skip through that. We're not doing OmniPath, so we'll skip through that. And then now we get into configuring and setting up Werewolf. So they even mark this here. By default, Werewolf is configured to provision over the ETH1 interface, and the steps below include updating the section override with a potentially alternative named interface specified by SMF ETH internal. So if we didn't set this to ETH1, if it want to go ETH0, ENS1, whatever I want to call it, this command set will let you change that. So that's where we're going to stop for today, because the next video is we're going to have the Rocky system installed, at least the base OS, get it patched and ready, and then we'll go through all the steps we've written down in this spreadsheet so far and mark them green or red, and then figure out what caused the problem. And that will be our first steps into building an Open HPC cluster. And then from there, we'll create provisioning, create a image to provision off of, stand up our virtual machines where we've probably already stood them up because we need those MAC addresses. And then we'll kick off provisioning and make sure that it provisions a node and attaches it to the Slurm cluster, and a lot more. This will make sense as we go through it. And then we can send a batch job to it and it will run computations for us. So that's it for this one. Stay tuned for part 2, and we'll see you in the next one.